Okay, we're going to be learning about the graphs of tangent and cotangent, the parent function, and then we're going to be taking a look at some translations, really in particular of a tangent graph. Okay, so if you can do the tangent, you'll figure out the cotangent, no problem. So let's talk about tangent and cotangent. First thing we want to note is that in general, for y equal tangent of x, okay, and also for the cotangent of x, the period is just pi units. Okay, so the period is just pi units. So I'm going to write that down. We're going to graph both of these here. All right, the period is pi units for both of them. All right, now let's go ahead and take a look at the tangent graph. Well, if you know anything about the tangent, you know that it is y divided by x. Well, we have to consider, well, where was x 0? Because remember, in some cases like this, you cannot divide by 0. All right, you can't divide by 0, period. But in this case, we know that it occurs on the unit circle at pi over 2. So what ends up happening is we have a vertical asymptote here at pi over 2. All right, and then similarly, we have a vertical asymptote here at negative pi over 2. So I'm going to superimpose a line here that I'm then going to erase. But if you think about this right here, this is pi over 2 units. This is pi over 2 units if you're talking about the distance, right? So then in total, well, what's that distance between? Pi units, which corresponds to the period, okay, of the tangent graph. Well, the other thing we know is that the tangent is 0 at 0 radians because y divided by x is 0 divided by 1. So it has a kind of midpoint there for one period of the graph anyway. And the graph kind of looks like this. A lot of my students think, well, it looks very similar to like a graph of an x cubed. Okay, but what you need to remember is that this cycles. So the tangent graph actually, if you were to graph it on a calculator, might look something like that. Okay, but those are separate periods of the graph. All right, and we're only going to look at one period. So in general, this is the very most basic view of the tangent graph. As far as the cotangent is concerned, well, let's consider this one analytically as well. We know the cotangent to be x divided by y, in this case cosine divided by sine, whereas the tangent was sine divided by cosine, but the period also being pi. What happens here is that we know that at pi, we have negative 1, 0, negative 1 divided by 0 is not going to happen. Okay, we have an asymptote there at pi, and similarly we have an asymptote at 0. All right, so this is where we have an asymptote, and since we interchange x and y, it looks very similar to the tangent graph, with the exception that it's in the opposite direction because, again, x and y are being interchanged. In this case, at pi over 2, where x divided by y is 0 divided by 1, we have 0. But the graph otherwise looks just like this. And you'll see what I mean. We've interchanged x and y, and that's why the shape kind of changes direction. But this is one period, in other words, of the cotangent graph. And it's easier to see that this is one period because it does go from 0 to pi. And again, I need you to understand that the graph also repeats itself because the graph cycles. Okay, but we're only concerning ourselves with one period of this graph. So let's go ahead and take a look at a couple of graphs, and I'll write them out for you. We're going to take a look at some translations, okay? So let's go ahead and take a look at two graphs. The first one is going to be y equal the tangent of 2x. Well, if you noted up above, the period of the graph is going to be denoted by pi over k. So we're going to have pi, in this case, the period, being modified by pi over 2. Okay, since k equals 2. All right, so that's going to modify that for us. And then we're going to adjust our graph here. So when I say we're going to adjust the graph, what we're going to do is we're going to modify these marks here. All right, and we're going to modify them in such a way that we represent the period. So the graph is going to look the same really as the parent up here at the top. But in this case, if the period is just going to be pi over 2, okay, so pi over 2 right there. All right, let's just zoom in a little bit. The period is going to be pi over 2. Well, we're going to need to cut that in half. So this is half. So if you consider what is half of a half, it's a fourth. So this right here then is pi over 4. This stays at 0, and then this becomes a negative pi over 4. But as long as you've done that, then the graph pretty much stays the same. Your asymptotes now are going to be at negative pi over 4. All right. But the graph again looks identical to the parent otherwise. So we put our center here at the origin, and then we draw our tangent curve just like that. Okay, so we're going to go ahead and take a look at another example here. Okay, so the next example and the last example for this video is going to be the tangent of 2 times x minus pi over 4. All right, so what is this exactly? Well, this one right here is the same as the previous graph, okay, in that k is still equal to 2. All right, so the period has changed. It's no longer pi in this case. The period is going to be pi over 2. So very similar to this last one, but the difference here is the phase shift, okay? So the phase shift, and in the phase shift, the graph moves opposite the direction of the sign. So I know it says minus pi over 4, but it actually is going to move pi over 4 units to the right. So pi over 4 to the right. All right, so what I'm going to do is I'm going to mark these points here, all right, where before we had, suppose this one was a negative pi over 4 on our graph here to the left. All right, this is 0, this is pi over 4. If you add another pi over 4, that's 2 pi's over 4, so pi over 2. So what's going to happen, all right, and let me see if I can select this with my lasso here. Let's see if I can, I think I got it. What it ends up happening is that this is going to shift over right there. And that's actually kind of cool that I could use that tool there. But let's go ahead, put that back. And we notice what happened there. The asymptote shifted too. Where the asymptote was at negative pi over 4 before, it's actually going to move now to be at 0. So here is the new asymptote. And the asymptote previously was at pi over 4 is now going to move over to pi over 2 right here. Okay, so these are the new asymptotes because, again, the graph is the same as the previous in that the period was the same. What the difference is the phase shift. Okay, so that means that this little vertex, the center, if you will, of the tangent graph here, the tangent curve, is now going to be at pi over 4 rather than 0. So everything just got shifted over pi over 4 units to the right. And if it was plus pi over 4, then we'd move in the opposite direction. So again, now we're ready to draw our curve. Again, it looks kind of like a cubing function, if you will, and it looks just like that. Okay, so that right there is your tangent graph with a modified period and a phase shift. Okay, so 2 really good examples here of modifying a parent function. As always, I hope this video was helpful, and remember, like and subscribe.